Assalamualaikum warahmatullahi wabarakatuh and welcome to my YouTube channel. So before we start our discussion, so I would like you to subscribe my channel and like this video. Okay, so what we are going to do today, we are going to discuss about more concept. So before I go further, let's look at this picture. This is the picture of eggs. So how many eggs that you see? Okay. Is it 12 eggs or a dozen? Which one did you prefer? Do you prefer calling it as 12, a group of 12 eggs, or a dozen? So, dozen is the earliest primitive integer groupings used to represent group of 12. So, both are correct. Either you say this is a 12 eggs or a dozen. Both are correct because dozen is integer grouping that is used to represent the group of 12. Okay, now look at this picture. Delicious, right? Okay, so this is a picture of rice, of cooked rice. So how do you measure rice? How do you say, I want that amount of rice? How do you say that to your mother? Okay, so we seldom use a cup to measure rice. Either 1 cup, 2 cup, or for 1 serving of rice, is equals to 1 cup of rice is equals to 90 grams. Okay, so what about this picture? So this is the picture of carbon. Uh, this carbon on top of weighing balance. So we see here this carbon has weight 12 grams. So how many carbon atoms that present in this 12 gram of carbon? Can you calculate it? Can you determine how many carbon atoms? It is not like our eggs earlier. We know that in a dozen of egg there is 12 eggs. So right now in 12 gram of carbon, can you calculate? Can you determine the uh, how many carbon atoms? So what is the quantity unit that represent the quantity of carbon or other atoms? So that is what we want to discuss in this video. Okay, so that is the Avogadro constant. So we go before we go further to explain, to discuss about the Avogadro constant. So we should uh, know who is Avogadro. So this is the picture of Avogadro. So the real name of this person is Amedeo Avogadro that lived during 1776 and died in 1856. So he is an Italian mathematical physicist. Okay, he is an Italian mathematical physicist. He proposed the law that a concept that we call as Avogadro's law. So what is Avogadro's law? So by, by him under control condition of temperature and pressure, equal volume of gases contain an equal number of molecules. So Avogadro said that under control condition of temperature and pressure, equal volume of gases contain an equal number of molecules. Okay, so there is a raise an issue here. There is a raise a question here. So how many molecules that Avogadro mentioned here? How many molecules? So comes the second scientist, which is the name is Stanislao Cannizzaro. Okay, he is an Italian chemist. So he explained this number 4 years after Avogadro's death in 1860. Okay, so he proposed a proportionality factor that relate the number of constituent particles. Usually, so the particles that he mentioned is usually molecules or atoms or ions in a sample with the amount of substance in that sample. So he proposed that there is one proportionality factor that will relate the number of particles with the amount of substance in that sample. Like our example, before this I have rice, right? So how this proportionality factor relates the 1 cup with the 90 gram, or in the example of carbon, how 12 gram of carbon is related with the how many carbon atoms. So what is the proportionality factor that is proposed by this scientist? So the proportionality factor is 1 mole. So the proportionality factor is 1 and the unit is mole, and mole is the SI unit. So from this proportionality factor, 1 mole here, it is relate the number of particles with two quantity of mass and volume. Okay, it relates the number of particles with the mass and the volume. So for the number of particles, we call it as Avogadro number. And then for mass, we call it as molar mass. For volume, we call it as molar volume. So the proportionality factor relate these three components together. So how does it is relate? We look at the first one, Avogadro number. So these three items here, Avogadro number, molar mass and molar volume, these three uh these three uh these three items here, we call it as Avogadro constant. So this is the Avogadro constant. Means that we have three Avogadro constant, which is this first one is Avogadro number, second Avogadro molar mass, third molar volume. So how this proportionality factor with relates all of these three items. Okay, we go to the first one, Avogadro number. So Avogadro number is 1 mole is equals to 1 mole. Okay, how do it relate? It is said that 1 mole is equals to 6.02 to the power of 1023 particles. Okay, 1 mole represents 6.02 exponent 23 particles. Means that if you have 1 mole carbon, means that you have 6.02 exponent 23 carbon atoms. Then if you have 1 mole CO2, means that you have 6.02 exponent 23 carbon dioxide molecules. Okay, because the 1 mole here represents this number of particles. And then if you have this ion, so if you have 1 mole of carbonate ion, means that you have 6.02 exponent 23 carbonate ions. Okay, that is Avogadro. Okay, how about the second one? How this proportionality factor relates with mass? So the Avogadro constant here is molar mass. Okay, so 1 mole of particle is equals to mass of 6.02 exponent 23 particles in gram. Okay, for example, we have 1 mole carbon. means that in 1 mole carbon, the mass of 6.02 exponent 23 carbon atom will have weight about 12 grams. Okay, how about oxygen? For oxygen, 1 mole of oxygen will have mass equals to 16 grams. Okay. For carbon dioxide means that mass of 6.02 exponent 23 molecule of carbon dioxide has mass equals to 44 grams. So how about carbonate ion? For this carbonate ion, 1 mole of carbonate ion will have mass of 60 grams. So this is molar mass. And then we go to the molar volume. So for molar volume, 1 mole is equals to volume of 6.02 exponent 23 gaseous particles in liter. For molar volume, 1 mole is equals to volume of 6.02 exponent 23 gaseous particles in liter. So it depends on the condition where the gaseous particle exists. So if the particles are at room conditions, so the volume is 24 liter or dm cube. The unit here is same. And at standard temperature and pressure, the volume is 22.4 liter or dm. So if you have 1 mole helium, means that you have volume of 24 liter at room condition and 22.4 liter at STP. Okay. Second example, if you have volume of 1 mole oxygen, so at room condition it is 24 liter. At STP 22.4 liter. Okay. So I think that's all for my video. Hope that you understand all of these three Avogadro constant. The Avogadro number, the molar mass and the molar volume and how it is related to each other. It is related by the proportionality factor 1 mole. So that's all for my video. Assalamualaikum warahmatullahi wabarakatuh.